Welcome to the Deep Dive, where we take your curiosity and our research to unearth the hidden gems of knowledge. Today we're looking at a machine that, well, it pretty much powers our world silently, moving mountains of goods every single day. We're talking about the forklift. You sent us some really fascinating source material, a detailed breakdown of forklift parts from industry experts. Our mission today, to unpack the essential bits and pieces, the functions of this incredibly versatile workhorse, and reveal maybe some surprising complexity behind it. I mean, can you imagine moving all that stuff manually?
Yeah.
Just, wow, the forklift was really the solution. A feat of engineering, really. Okay, let's unpack this. What makes a forklift tick?
It is pretty remarkable, isn't it? Something we see, everywhere. Construction sites, local stores, everywhere. But the design is so intricate. And what's really fascinating is how every single component is designed for that main job, safely and efficiently moving heavy loads. Understanding these machines, it's really key to appreciating, well, the backbone of modern logistics. It's like you said, a hidden ballet of commerce.
A hidden ballet. I like that. So let's start right at the foundation. A forklift, fundamentally, is a work vehicle for moving heavy stuff quickly. Simple enough. But one of the really interesting things is this idea of 3 points of stability. Sounds a bit strange for something lifting tons, right? Can you maybe break that down? Why is that so foundational?
That's a really crucial point. The genius there is that tripod idea. So
Yeah.
you have the two front wheels and then the pivot point right in the center of the rear axle, not four corners like a car. And this setup, it gives it incredible maneuverability. It can turn really tightly, but still stay stable, provided the surface is pretty flat. It's just a very elegant solution for lifting heavy and being agile.
Okay, that makes perfect sense for like a crowded warehouse. Now, we are seeing more automated forklifts, computer-controlled ones appearing. That's definitely a trend. But it's worth remembering, most forklifts out there are still driven by people. The human element is still central.
Yeah.
So this foundational design, it leads us to three major parts that form the core structure.
Exactly. And these aren't just, random parts. They're the pillars for power and safety. You've got the forklift frame, the overhead guard, and the hydraulic lift system. Absolutely fundamental.
Let's focus on the forklift frame first. That's literally the backbone, isn't it? The chassis, the base, everything bolts onto this.
Mm-hmm.
The mast, axles, counterweight, that crucial overhead guard. Plus it holds the hydraulic fluid and the fuel tank, or maybe the battery. It's the skeleton.
And that skeleton leads straight to the counterweight. This thing is absolutely critical. It's what stops the forklift from tipping over, especially with a heavy load way out front. The clever bit isn't just the weight itself, but how it allows the forklift to be so compact. It doesn't need wide legs like a crane. The weight's built right in, usually at the back opposite the forks. This means it can lift huge amounts and still zip around tight corners, quite an engineering feat. And in some electric ones, the battery itself is so heavy it is the counterweight. Very neat, dual-purpose design.
That integrated design is really smart. Okay, speaking of staying stable and interacting with the ground, let's talk tires. The forklift's feet. I understand there are basically three main types, each for different jobs. That must reflect all the different places they work. First, cushion tires. Solid rubber, right? Wrapped around the wheels. Best for indoors. Smooth warehouse floors, paved areas, they ride lower. And that low profile means a tighter turning circle. Great for those really tight aisles, like ballet slippers. Precise.
Exactly. Indoor specialists.
Then you have pneumatic tires. Now, these are also solid rubber, which is maybe a bit confusing given the name, not air-filled.
Right, that's a key distinction. Solid rubber pneumatics.
They're apparently the most common, very durable, long-lasting, more expensive maybe, and not as smooth a ride, but versatile.
Yes, that's the key word, versatile. They can handle both indoor work and going outside onto, say, a loading dock or storage yard. The all-rounders.
Got it. And finally, pneumatic air-filled tires. These are the ones more like car or truck tires.
Yep, rubber filled with air.
More durable for rough stuff, deeper tread for traction, best for outdoor use, right? Uneven ground.
Definitely. They handle rough terrain better, give a bit more cushioning for the operator to think construction sites, lumber yards.
So why all these types? Why not just one?
Well, it's all about optimizing for the environment. And trade-offs, really. Cushion tires are agile indoors, but useless outside. Solid pneumatics bridge the gap. Tough, but maybe rougher ride. Air-filled give comfort and traction outdoors, but you risk punctures. So the choice directly impacts efficiency, how long the forklift lasts, even how tired the operator gets. It's about picking the right tool for the specific job.
That makes sense. It's not just a tire, it's the right tire. Okay, let's climb inside the machine, the operator's area, the forklift cab. This is the space in the frame where the driver sits. Got the seat, the
The
controls,
command center, basically.
and inside there, the forklift seat. Place for the operator, obviously.
Yeah.
Right in front of the controls. Most sit-down ones have seat belts, which seems like a good idea. And interestingly, some models are designed for standing operation, for certain tasks where maybe visibility or hopping on and off quickly is key.
Yeah, you see those in specific picking operations sometimes.
Then the forklift steering wheel. Pretty standard, lets you turn the wheels. Some have that little knob attached for spinning the wheel quickly, especially in tight spots. Makes one-handed steering easier.
Yeah, the spinner knob, very useful for maneuverability, shows that focus on operator ease of use.
But steering is just one part. There are those crucial forklift levers, usually right near the wheel. Three main ones.
Typically, yes, for controlling the load itself.
First, the tilt lever. This controls the angle of the forks, tilting them forward or back relative to the ground.
Vital for scooping under a pallet cleanly or keeping the load stable when raised.
Then the lift lever. This one's pretty obvious, controls the height. Uses hydraulics to raise and lower the mast and forks.
The main lifting control, yeah.
And the third one, the side shift lever. This lets the operator move the whole fork carriage left to right slightly.
Exactly. Small lateral adjustments without moving the whole truck. Hugely helpful for precise placement.
So with all this lifting, moving, tilting, heavy loads, tight spaces, safety has to be absolutely critical. What are the main things built in to prevent accidents? Any surprising safety features?
Oh, absolutely paramount. Safety drives a lot of the design. Two things stand out immediately. First, the forklift overhead guard, that cage-like structure above the operator. Its main job is protection from falling objects. You know, something getting knocked off a high shelf. It's why operators also need hard hats, and crucially, they have to keep hands and feet inside the frame. Always.
Right, that makes sense. A protective shell?
Yeah.
What else?
The forklift load backrest. This is that grid or screen attached to the carriage, right behind the forks, running vertically. Its job is simple but vital. Stop the load from sliding backward towards the cab and the operator if something shifts. Protects the driver, protects the machine. The rule is clear: never operate without it. It's a fundamental safety barrier.
Simple but effective. Okay, those are non-negotiables. Let's get to the real muscle, the lifting part. The forklift mast. That's the big upright structure that does the actual lifting, holding the forks. I understand there are different types of masts, too. Depending on how high you need to lift, maybe visibility needs.
Yes, exactly. Different mast designs, simplex, duplex, triplex, offer different lift heights and collapsed heights tailored to the application. Some allow free lift, which means the forks can rise a bit before the mast itself starts extending, good for low doorways.
Interesting. And doing the pushing within that mast is the forklift main lift cylinder, hydraulic cylinder, right? That pushes the mast up.
That's the one. Hydraulics provide the power.
The control valve sends fluid in to lift it. And then there's a flow control valve for lowering smoothly.
Correct. Controls the descent speed, prevents it from just dropping. It's
Right.
all about controlled power.
But how does that relatively small cylinder lift such heavy loads?
Ah, the magic of hydraulics. It's Pascal's principle in action. You apply force to a confined fluid, and that pressure is transmitted equally throughout. So a small input force on the hydraulic fluid creates immense output force in the cylinder, allows you to lift tons with, relatively speaking, manageable hydraulic pressure, same idea as in excavators or dump trucks.
That's fascinating, leveraging physics like that. Now, we shouldn't mix that up with the forklift tilt cylinder.
Right, different job, also hydraulic, but these control the tilt of the mast.
Usually two of them, to provide that forward and backward tilt control we mentioned with the lever.
Precisely. Gives the operator fine control over the angle of the load. Crucial for stability and placement.
And tying the forks, the backrest, and connecting to the mast is the forklift carriage. It's the whole assembly between the mast and the load itself. Includes the forks or tines, as they're often called.
Correct. It's the interface with the load, and it's also the mounting point for attachments.
And these carriages come in different classes, based on height and lifting capacity.
Yes, 5 classes, Class A through E. It standardizes the mounting for forks and attachments, and it directly relates to the forklift's rated capacity. Class A for lighter loads, under about 2,200 pounds, up to Class E for really heavy stuff, like 17,000 to 24,000 pounds. Shows how tailored these machines are.
Okay, attachments. This is where things get really specialized, isn't it? Beyond just the standard forks or tines, what about those extra tools that let them handle specific jobs even better?
Ah, yes, the attachments. This is where a forklift goes from general purpose to, well, a specialist tool. Forklift attachments modify the machine to handle loads more efficiently than standard pallets allow. They can let the forklift push, pull, lift, rotate, shift sideways, even clamp onto things. Picking the right one can seriously boost safety, cut down on product damage, and just make the whole workflow faster. It's about matching the machine precisely to the product being handled.
Like a Swiss Army knife for moving stuff. Let's talk examples. The side shifter sounds incredibly useful. You mentioned it with the levers.
Oh, it's probably the most common attachment out there. For good reason.
It lets the operator nudge the load left or right without repositioning the whole truck.
Exactly. Saves so much time and hassle lining things up perfectly. Reduces pallet damage, too, because you're not constantly reforking.
And you can stack things closer together, save warehouse space. Yeah, I can see why that's a game changer day to day.
Huge efficiency boost.
What else? A paper clamp for handling big paper rolls without squashing them. Makes sense for printing industries.
Yep. Specialized clamps are common for specific products. Paper rolls, bales of cotton, appliances.
A fork positioner lets the driver adjust the fork width hydraulically instead of getting out and doing it manually.
Another big time saver, especially if you handle lots of different pallet sizes throughout the day.
And a push-pull attachment for handling things on slip sheets instead of pallets.
Right. Slip sheets are cheaper and take up less space than wooden pallets. Common for things like drinks, packaged foods, cement bags. This attachment grips the sheet and pulls the load on, or pushes it off.
Clever. And fork extension seems simple enough, just make the forks longer for bulky items. More stability.
Simple but effective for occasional long or awkward loads. Increases safety.
And finally, a multiple pallet attachment to handle 2 or more pallets side by side.
Yeah, doubles or triples handling capacity in high volume situations. Think loading trucks quickly in manufacturing or distribution centers. Big productivity gains.
It's incredible how these attachments customize the machine.
It really is. It shows a deep understanding of specific industry needs. It's not just about moving A to B, it's about how you move it, how efficiently, how safely. Impacts costs, speed, everything.
Really changes the whole equation. Okay, shifting gears slightly. Power. The forklift battery. Modern forklifts often run on rechargeable batteries, right? Lead acid or the newer lithium-ion.
That's increasingly the standard, especially indoors. And yeah, these aren't your phone batteries. They're massive industrial units, often weigh thousands of pounds.
And the big plus is sustainability. Saves on fuel costs, cuts CO2 emissions, good for the budget, good for the environment.
Definitely a major driver for electrification in this space. It's a win-win.
So you've got the power source sorted, but keeping these machines running consistently, especially in demanding places.
Ah, now you're talking about uptime. And that brings us to forklift spare parts. For places running tight schedules, maybe just-in-time delivery models, downtime is poison. So, keeping an inventory of common wear parts, brakes, chains, the forks or tines themselves, tires, filters, hydraulic bits, it's crucial. It saves time, saves money in the long run by avoiding waiting for parts while a machine sits idle. It raises that whole question of operational resilience, doesn't it? Planning ahead.
Absolutely. Proactive maintenance and parts management. Makes total sense. Wow. We've really taken a deep dive today, uncovered quite a bit about the humble forklift. From that 3-point stability, the specific tires, the hydraulics, the safety features, right through to all those clever attachments.
It's surprisingly sophisticated when you break it down.
So what's the takeaway? I guess it's that this machine, which we might barely notice, is actually a cornerstone of efficiency and safety in so many industries. It's way more than just a truck with forks. It's some serious smart engineering solving real-world problems.
Exactly. So maybe next time you see one, you'll appreciate that hidden ballet a bit more. The hydraulics, the counterweight, maybe a specialized attachment doing its job. And think about how this seemingly mundane machine is critical for getting almost everything you buy to where it needs to be. Constantly evolving, too. Makes you wonder, what other everyday machines are hiding that kind of sophistication just under the surface?
That's a great thought to end on. Hopefully this deep dive helps you see the world around you just a little differently. Thanks for joining us.